Okay, so under biology there, we're going to look at enzymes. And under enzymes there, we're supposed to understand what enzymes are. So enzymes, in short, enzymes are proteins in nature. Enzymes are protein in nature, but you find that a lot of books you find different definitions. Others you find that enzymes are complex proteins, molecules folded in three-dimension shapes. Or in other terms, in simple terms, we can say enzymes are proteins in nature. Now, these enzymes, what do they do? They act. So enzymes, they act as the catalyst. They act in biochemical reactions and they act as the catalyst. But we're supposed to understand what a catalyst is. So a catalyst is a chemical substance that speeds up a chemical, or that speeds up a chemical reaction without itself being used. So all catalysts are chemical substances that speeds up a chemical reaction without itself being used. So in other terms, when you go further, maybe in physics, you find that what does a catalyst do, especially in chemistry, there's a topic under rates of chemical reaction. What does the catalyst do in order to speed up the chemical reaction? What does it do? It lowers the activation energy of the reaction. So as a result, it will speed up the reaction. If the reaction maybe was supposed maybe to start reacting maybe at 10 minutes, but if you add a catalyst, instead of the reaction starting to react at 10 minutes, it will start maybe at 5 minutes or maybe at 2. So it lowers the activation energy of that. Now we're supposed to look at the characteristics of what? Enzymes. One of the characteristics of enzymes is that enzymes are specific. They are specific. Now, what does it mean? When something is specific, it means that they act on specific substrate. It's not all enzyme. Maybe enzyme for proteins, enzyme that act on proteins cannot act on what? Carbohydrates. So why carbohydrates? Mean that carbohydrates. So mean that these enzymes that act on proteins, they cannot react on carbohydrate food. For example, starchy food. No, that's why we're saying that enzymes are what? Specific. They act like a lock and a what? And a key. Every lock has got a specific key to open it. That is how enzymes they are as well. So for example, we can have maybe an enzyme of this nature. Let's say this is an enzyme. Let's say this is the enzyme, okay? Then the only substrate that this enzyme can act on is something that has got of its shape that can fit in this. So the substrate can be in this manner. You cannot have a substrate of this coming to act. Why? Because this one, the shape of this one cannot fit there. That's why we're saying enzymes are specific in nature. So this can be the substrate. So let me just shade it. So this can be a substrate. Now, you can be asking, what is a substrate? Okay, what is a substrate? A substrate, okay? A substrate, in short, it is the food. This is the food on which the enzyme act on. So all the food, maybe we can be protein food, those ones, they fall under substrate. So substrate is the food on which an enzyme acts on. So meaning that when you look at this, what will happen? This is going to fit into this. As a result, you can have something which is in this manner, and then this is going to fit here. So this is an enzyme, and this is a substrate. The region in which the enzyme, the substrate fits is what you call the active site. The active site. So the active site is the region or the boundary in which the substrate fits. Then we're going to have these two here. You're going to have an enzyme and the substrate combined together. Then that means that this is where now the enzyme is started now acting. So this is what you call the enzyme substrate what? Complex. This is the enzyme substrate complex. After that, what will happen? The enzyme will remain in its what? In its shape. The enzyme will remain in its shape like this. But what happens to the substrate? Now that one stops being the substrate, now becomes the product. Now, when the substrate is broken down, what we produce is what you call the product now. The end product. These are the end product of that substrate, and then the enzyme will still what? Remain. These enzymes remain unchanged. That's why we say that the enzyme are biological catalysts, meaning that they do not take part in the chemical reaction, but they will just catalyze it. They will break down, but themselves they are not. So this enzyme will wait again after the substrate again comes in, which is in this shape. Again, this enzyme acts on, then waits, and then acts on, wait, again acts on, just wait. So these are products. For example, if this was a protein one, so let's say if this was a protein substrate, okay, what will happen? So it means that here there will be enzyme, the substrate, which is the protein. The end product of proteins after digestion, we call them as what? Amino acids. Others, they say amino acids or amino acids. So these will be the end product, amino acids. So this will be the end product. That means that when proteins are digested, what we get is the amino acid. The amino acids are the products, and then the protein now is the substrate, which is the food on which the enzyme is going to act on, break it down into molecules. Now, there are some factors now that can affect the rate of this enzyme activity. And one of the factors that can affect the enzyme activity is the temperature. Okay, one of the factors that can affect the enzyme activity is the temperature. Is temperature. Okay, how does temperature now affect the enzyme activity? So let's start with the temperature. So as we're increasing the temperature, the enzyme activity also increases. But there is a certain point at which the temperature can be increased to. Beyond that point, what happens to enzymes? Enzymes can be denatured, enzymes can be destroyed. So mean that when you look at the temperature there, we can have a graph there. Let me draw a graph. Then here you can have, let's say, okay, there. We have a graph like that, okay, in that manner. Then we can have rate of reaction, the rate of reaction this side here, and then here you're going to have temperature. Okay, let's have temperature in this manner. So what is happening? The temperature is increasing from 0. What happens? The enzyme also is inactive, but it will start also increasing. As the temperature is increasing, also the rate of reaction of an enzyme increases. Then when the temperature reaches a certain point, what happens? The graph starts falling. What does it mean? It means that this other part, the enzyme has been denatured. Let's say, for example, for human being, this is 37 degrees Celsius. That is the best temperature at which enzyme works well. That means that this point here is what we call optimum. Optimum what? Temperature. Optimum temperature, it is the temperature at which an enzyme works best. That is the best temperature ever, and that is where you're going to have a lot of products there. So in other words, or in other books, you can find that optimum, it's the most favorable condition or amount. So mean that it is is the temperature at which an enzyme produces the highest reaction rate for that specific reaction. This is the optimum temperature, the best. But this side here, the enzyme become what? Denatured. What does it mean? It means that the enzyme is what? Destroyed, denatured. It is destroyed. Why? Because the temperature becomes above the normal temperature. That's why you find that people at 40 degrees Celsius, you cannot even be alive. You have already died. Why? Because the enzyme at that point have been denatured. That's why you cannot be in too much heat. That's why when you're sick, when you go to the hospital, the first thing that they will do is to check your body temperature, because there's some certain things that happen in your body that will just increase the temperature. So they need to make sure that your temperature is under the optimum there before they administer anything. So at this moment, but here the enzyme will be inactive. Again, when it is too cold, there are people that will die at pneumonia. I think you've heard of that. That is a disease when somebody dies due to what? Too much maybe loss of heat. Again, the enzyme at that particular time becomes denatured. I mean, becomes inactive. Here it is inactive, but here it becomes active. So as the temperature is increasing, the enzyme activities. But at this moment, that is the best temperature at which that. Then after, beyond that, then the enzyme is denatured. How is it denatured? Maybe, for example, let's say the shape of that enzyme was in this manner. The substrate is like this. It can only. But when the temperature is beyond, what happens to that enzyme? You find that that enzyme maybe, instead of being that shape, maybe the shape maybe becomes like this. Now, this is, let's say, the enzyme maybe, for example, pepsin now. Pepsin, the one that acts on proteins. Now, this one now becomes pepsin. The substrate will still come in this manner. That means that the substrate cannot fit there. As a result, there cannot be any protein digestion. And there is no way you can be alive. If there is no protein digestion, it means that the person is going to what? To die. So that is how temperature affects the enzyme activity. Then the second one there, the second one that we're going to look at is enzyme and substrate. In short, substrate. How does the substrate affects the enzyme activity? Substrate, we're talking about the food on which an enzyme acts on. Now, what is happening to your body? The more the substrate, the higher the rate of enzyme activity. That's why you people, when you, maybe for example, last night, if you ate too much and you are very full, when you wake up in the morning, you're going to wake up very hungry. Why? Because there was too much of the substrate, there was too much of the food. As a result, the enzyme increased their reaction to break that down. So the more the substrate you have, the higher the rate of enzyme activity. The higher the reaction, the higher the enzyme are going to break down that food. That is about the substrate. So the more the food is, the higher the rate of reaction there. So the reaction becomes more if at all there is a lot of substrate concentration. So an example of a graph that I can draw here, you can say rate of reaction here. The rate of reaction, but here you can talk about substrate concentration. So as you are increasing the substrate here, what is happening? The enzyme is also increasing, just like that. But or maybe an example, you slept yesterday. So we can have maybe even two graphs there. If you check about these two graphs, you can find out that maybe this one, the concentration of substrate was less than this one. Here, this reaction is higher than this one. So this one we had more substrate, but here we're doing less. When you just eat a little, maybe for example, just eat maybe 2 lumps, so to say, or maybe just one, or maybe you just take tea at night when you sleep. In the morning when you wake up, you're not even going to feel hungry to say, okay, I want to eat, and that. Why? Because there was less food. Since the food was less, so the enzyme activity also became less. But the more you eat, the more food you have in your body, the higher the enzyme activity. So that is about that. And then the last one there, we're talking about the effect of pH on the enzyme. Now, pH is how acidic and alkalinity a substance is. So on the pH scale, you have, so there is pH, effect of pH. So pH also affects the enzyme activity. How does pH affect the enzyme activity? So the pH, like I said, is how acidic and alkaline a substance is. So on the 7 part here, 7 number, it is neutral here. Then this is 0 and this is 14. So this part here from 7 coming this side, this is acidic. And then going this side, this is alkaline. Okay. Now, what is happening is that enzymes do not get denatured if the pH is increased. No, the enzyme just stop reacting. An example that I can give you is, let's say, maybe a graph. Let me draw a graph there. Let me draw a graph like this. This is about pH rate. Again, rate of activity of enzyme here, and then here you can talk about the pH here. So let's say there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so you find that this is where it is neutral. So you find that there are some enzymes such as pepsin. Pepsin is for this side here. Pepsin, it is an enzyme which is found in the stomach. Now, the stomach is said to be acidic because it contains what you call hydrochloric acid. So you find out that as the pH is increasing, bestly it works best at 2, that is optimum pH. So when the pH increases, when it reaches somewhere 2 there, it starts to fall there, then it goes this side. Okay, let me just say like this, okay? Now, at 2 here, this point here is what we call optimum what pH. According to what we had also optimum temperature, it is the best temperature, or the most favorable temperature on which an enzyme acts. So even for pH, this is the best pH agreed. But as the pH increases, what is happening? It is becoming less acidic. As a result, you find that the enzyme activity stops. But they do not get denatured at this moment. No, they will just stop. This one, pH does not denature the enzyme. The enzyme just stops reacting. It's more like you only react when you are at home. When you're at home, you can do anything that you want. But when you move from your place, you go somewhere else. There are some certain things that you are restricted to do. It means that you cannot do the way you do. Maybe you sit on the couch, then you even put your legs on top there. You cannot when you go somewhere else. That means that you are changing the environment. So the environment is changing from the more acidic to a less acidic. So it does not mean that it stops working, but I mean, it does not mean that it is denatured, but it will just stop operative working until it becomes acidic. So in short, like I said, you move from your place where you can step on the couch, you step on the tables, you eat anything that you want. When you go somewhere else, what happens? There are some certain things you cannot step on because that is not the region where you can do that. But once you go back, the region now becomes favorable. You go back home, you start doing the same thing. That is what is happening here. So when the pH increases, the enzyme stops reacting, but it is not denatured. It will still be there. So pH does not denature the enzyme. It just stops the activity of the enzyme. There are those enzymes such as, let's say, trypsin. Now, again, trypsin is an enzyme that continues the digestion also on proteins. Now, from pepsin changes to peptides, and then trypsin will continue from peptides to amino acid. Now, this enzyme is alkaline. It can be here, but it is inactive. It is not. Why? Because the region is acidic. For it works in what? Alkaline. Alkaline. So, but this one here needs where it is acidic. So when this one is where it is acidic, it does not work. It is inactive. But when it reaches where it is alkaline, what happens? This now becomes active, but this one becomes what? Inactive. That is how pH affects those enzymes. So the other one is salivary amylase also, which is at 7 there. So you find that maybe here it is inactive, then when it reaches there it is. Then again we can have other enzymes such as trypsin, those ones, and then these are optimum pH. So this enzyme here cannot work in this region. Why? Because this one is only for acidic. It cannot. If it is here, if it is found in alkaline, it is going to be inactive. It is going to be there but inactive. But once it becomes acidic, it becomes active. Those that are working in alkaline cannot work in acidic. So that is how pH affects. So pH does not denature, but it only stops the enzyme to be active there. Okay, so that is about that. And then the last part there that we're looking at is the industrial application of enzymes. Where are enzymes applied, or what is the importance of this enzyme that we're talking about? So when you talk about industrial application of enzyme, one, uses. Okay, let me just use this part of the board. Uses of enzyme, because it's the last part. Now, when you look at uses of enzyme, one, enzymes are very important to your body, and one of them, they are used in, for example, food processing, such as baking. Okay, we use them in food processing. Okay, food processing here e.g. you're talking about baking. In yeast, there are enzymes that make the dough to rise. So when you do your flour and then you add some yeast there, then the enzyme in yeast are going to react, then they are going to make the flour to rise, the dough to rise. Then apart from that, brewing. In order to make alcohol, these maybe chibuku to be maybe kuvila, so to say. To ferment, in short, in fermentation, brewing. When you're making in fermentation, they use enzymes. The enzymes are the one that helps because the biological catalyst just speed up the chemical reaction. So they speed up the fermentation of what? Alcohol. Then apart from that, and also in fruit juice production, leather goods polishing, we use that. Detergents, such as maybe we're talking about mabumu or these. That's why sometimes you find that paribumu or maybe the other one, they will write to say multiple enzymes. So in detergents, the other one, it is used in detergents. We're talking about the masafu, all these household cleaning agents, such as mark powder, machani, all those, and also in textiles. In textiles, we use also enzyme. But I'll be able to send some uses so that you can be able to go through that. All right.